on this computer.
Okay, it's recording. I think everything's set up and you can share your screen and begin.
Okay. All right, hi everybody, and welcome to, I'm sharing my screen. Do we have participants and are we ready to go?
I'd just like everyone to just type a little hi in the group chat just to know if we have some people viewing. Full names. What's okay. So I think it's fine for you to start, even though there's not too many people here. The recording will be there for people to view later on. So I think you can skip that icebreaker bit you were planning.
Okay. All right. Got it. All right, hi everybody, and welcome to our 6th annual MasseyHacks. Today it's May 30th, and you're going to be hacking all the way until May 31st. So I hope you're ready for this. It's going to be our 6th annual. So welcome. I'm glad to see you or hear you. And you have signed into the introducing to Arduino presented by Miss Beiko, which is me. Okay, so I am going to get started. So we are going to skip past this one. Just if you're using Zoom, you have a chat section.
We also have a few people on YouTube Live, so if they have any questions, I'll convey them to you. Okay, so the Arduino, if anyone's familiar with Arduino, okay, great. I'm still getting the feedback from the YouTube Live in my, sorry. Okay, so we'll get started. Arduino is a microcomputer. So it has a CPU, a RAM, and an interface so you can interface it to your computer. So if any of you have taken computer programming at your high school, you would be familiar with the Arduino. Okay, so what can we use this microcomputer for? So we can develop interactive objects, like for example, a remote control vehicle. We can use various sensors with it that you can add to it. You can control your lights, you can control even a plant. Let's take a look at, I've got a few screenshots of some projects that I just found on the internet. I thought this one was really cool, and I've seen it in my classroom before.
So this project, you would create a box of some sort, and on the front of it, you're going to put an LCD screen, and you're going to put a keypad. And what they did at the bottom was they used an ultrasonic sensor to detect motion, but you didn't necessarily have to use the ultrasonic sensor. You could just use the keypad with the LCD screen, and then you would keypad in like a code and it would open up the box. So they've used like a buzzer to work with the keypad. Really cool project, and you could try something like that. Another project that you could do with the Arduino project is if you have a plant in your house, you could add in one of these soil moisture sensors. You add it into the soil of the plant, and it's going to constantly monitor that soil wetness and respond back to the Arduino. You can even set it up within a Twitter account, and it can Twitter you know, messages like I need water, or I'm having a great day, or you can actually make your plant have some kind of a life to it and really communicate with you through Twitter. So that's a really cool project as well. So on this next screen, I have a few different Arduino boards that you may or may not have seen them in the past. So up at the top left, we have the Arduino Uno, and that is the board we're going to use today. But I just wanted you to be aware that there's a few other ones that you can use in your travels and as you tinker around with Arduino. So let's take a closer look at the Arduino. So this one has a USB, top left is a USB connector. This is where you would connect it to your computer and interface with it. You would set up the programming and upload the programming. Underneath that, if we go down, it has an external power supply. So if you had the AC adapter, you could connect it, and then you wouldn't have to necessarily have it connected to your computer. So that's really cool if you want to like add it to a remote control car and run it off of a battery supply or any kind of thing outside of your computer. So this next one, power pins, is pointing to our 5-volt power pin on the Arduino, which we'll get familiar with in a little bit. We've got 6 analog inputs here at the bottom. Going over to the right, we've got our AT Mega AVR chip on board our Arduino. We've got our reset button. So if we need to reset our code or reset up the Arduino, we can press this. We've got our power LED. So when we plug in our Arduino to our computer, we have the power LED to verify that it's actually up and running. And then we've got 14 digital pins and 6 PWM pins. So PWM stands for pulse width modulation. We'll talk about that in a bit, and I'll show you what those look like. And then we've got, I don't know if I talked about this one, so to the left of that it says TX-RX LED. So that's like your input output LED, and it's built on board. So you can run a program with just the Arduino alone for starters and just to test it out. You don't need to connect anything else to start with Arduino. This just gives you a top-down picture. You'll notice these digital I/O pins. You can, if you look closely, like on pin number, you'll see they're all numbered to 13, 12, 11, 10, all the way down to 1. And if you notice to the left of number 11, there's like a little squiggly line. The squiggly line or tilde is to the left of 10 and 9, 6, 5, 3. And those are all our PWM pins. That's how you determine which one is a PWM pin. So let's talk about PWM for a minute. So we have on our Arduino board, we have digital and analog pins. So our digital pins are on or off. That's the only thing that they can do. So it's similar to your light switch in your room, where it's you flick on the light, it's on. If you flick it off, it's off. That's it. But your analog pins, you can get a reading, like say 0 to 255. So if you're, say you're using a temperature sensor and you want to have the temperature in the room, you can get this from the analog pins. But you only have so many analog pins on your Arduino board. So if you want to, you can use the PWM pins and get an analog similar reading by using the PWM pin and use the analog functions. So that's why we have those PWM pins. Okay, so let's talk about some really exciting news for all of our attendees on this workshop. You get to have an Arduino hardware kit. This is so amazing, I think, because personally, I've gone to many workshops before in the past, and I did not get to go home with an Arduino kit like this. I paid, I think it was like $800 to attend a workshop one time. I had to stay in a hotel, pay for the hotel, attend the workshop, and I didn't get to come home with a kit this nice. So I'm going to go through what all the contents of your kit, and you're going to be able to practice at home. So this is excellent. So as you can see, you're getting an Arduino Uno. You're getting a breadboard. You're getting 5 LEDs. You're getting 3 different types of resistors. So you're getting the 10K resistor, the 220, and the 1K resistor. You're getting some jumper wires to get you started, a push button, a potentiometer, and let's go. That's not it. Let's keep going on what this kit is going to contain. You're going to have an LCD screen. So a servo motor. You're getting a buzzer, which makes noise. So it's also called a piezo. And you're going to have a Bluetooth module. So you can connect your Arduino to your phone maybe and do some really cool Bluetooth things. You're going to get the ultrasonic sensor. And then you're going to get a 5-volt relay. So really awesome stuff in your kit. And I'm going to show you some things so that when this session is over with and you get your kit at home, you'll be all ready to start playing around. So I know that we're doing this all virtually, but I wanted to take a few minutes just to go through when you get your kit at home, what you need to get started. So I don't know if you've visited this website yet or not, but arduino.cc, and you need to download the Arduino IDE software. There's also an Arduino web editor that you can use to code online if, say, you're in the classroom and you can't download software to that computer, you can use the web editor. I recommend just downloading the IDE, and then you can save the files, you know, since we're working at home anyway, but you can choose which one you would like to use. Then you're going to need to, and we'll talk about coding and all that in a little bit, but I want to show you. So you would connect your Arduino using the USB cable and connect it to your computer. Your Arduino IDE is going to look like this. You're going to have a shortcut probably on your desktop, and you would just fire that up, double click on it. So your very first program, with just your Arduino, you could click on the File menu, go to Examples, Basics, and hit Blink, and use that built-in, this is a built-in program, comes with the Arduino IDE, and it can get you up and running right away, and you can use in that built-in LED and see it flash right away without even building a circuit. So here's some of the code that would be part of that Blink program. I'm not going to take the time right now to go through the code line by line because we are going to get into code down the road. So we'll skip through this and get into some more. So before you upload, when you're in your IDE and you have your Arduino connected to your computer, you need to go to up to the top where your tools menu is, go down to board and over to the right and make sure you're set up for the Arduino Uno. Also on the tools menu, you need to check your serial port. So go down to tools, serial port, over to the right, and make sure that you have a check mark to the left of the COM that you've set your USB up to. Because if you have your cell phone connected to your computer at the same time and it's charging, it might be connecting to your cell phone and not the Arduino. So you want to check those two things before uploading. Once you click on, you got those all checked, you're ready to go, you've got your code in your IDE, click on this right arrow, and this is your upload button. This is your built-in LED pin, so this should start flashing right away. So let's just talk briefly about the development environment, the IDE that you're going to use. So it has a file, like a toolbar up at the top, same as your Word document. You've got file, edit, sketch, tools, help. You've got a toolbar right under that with your upload and your verify buttons. You've got a text editor where you're going to write all your code. Most of the time you're going to just be copying code or using the built-in, but if you want to modify or change anything, the code window is there for you to do that. And then your message area underneath, once you compile and run code, it will give you feedback telling you whether the code compiled correctly. If it's run, any output statements that you have will display there. And then at the very bottom, you see like a text console screen. And if you have that option checked off, you can output commands to this output window. So in Arduino IDE, we call this program a sketch. So when we refer to a sketch, it's really just the code that you've opened into your IDE program window. Okay, so let's talk briefly about the different components of your sketch file. So you're going to have many comments throughout your sketch. Sometimes they're going to be separated by a backslash, star, star, backslash, if you have many, many, many different lines of comments. Sometimes it's just going to be a short, like added to the back of a line. So if you notice at the bottom, so at the bottom of this screen here, we have a code line. You'll notice here at the end, right here, this is the comment. And all of this afterwards, LED connected to digital pin 13, this is the comment. And then this at the front is our actual code in that line that gets compiled. Okay, let's talk about some variables that we're going to see in our sketch. So if you're in computer science class, you know what a variable is. Since we're in the advanced stream, I'm just going to briefly touch on this quickly. So you'll notice that we have a variable name. So for example, a variable name might be LED pin. We have a type. Very common type in Arduino is integer, which is represented by INT.
And then oftentimes we're going to set it up with an initial value. So for example, in this code line, we have integer type, int, LED pin is our variable name, and we've initialized it. So we have the equals sign, 13, and then we have our semicolon afterwards. Every line ends in a semicolon in Arduino C programming. So components of our sketch file. So in Arduino, we use a lot of built-in functions. There's many functions that are built in, and we just need to call them. Another programmer worked real hard creating all these functions, and we're just going to use them. So two components that you always have to have in your sketch file are the setup and the loop. Setup and loop. To remember what these are used for, setup is just that, setting up all your pins, maybe setting up variables, initializing things, and this runs only once when the sketch is run. And then we have our loop function. So the loop will continuously run over and over again. So you may put in a loop there, you may want a LED to continuously flash, may turn on and then it may turn off, and then continuously do that. If you're using like a LCD display, maybe it's going to scroll through continuously. Okay, so let's get started on Tinkercad. So to make things easier for you, I've asked that you set up a Tinkercad account ahead of time. So if you're watching this on your screen, you should have this and then another window opened, and open up your Tinkercad window. I've set up this Google Docs, and this is the link to the Google Docs. Maybe if I still have a helper, they could copy this into the chat window.
Okay, could you copy paste that? I can't copy paste
Okay,
that
let
unless
me
you send
copy
it.
paste this.
A lot of people are on the YouTube one, so if you copy paste it here, I can send it over there.
Okay. Okay. Yes, I'm copying right now.
Yep.
Okay, I don't chat. There we go. Hopefully this will help you. So yeah, so to make it easy for you to set up all of your programs instead of coding forever, I've kind of put a screenshot of what the program is. And at this point, I'm going to switch over my screen. I'm going to go to my Tinkercad.
Did you send it in the general chat?
I did. Do you not see it?
I do not. If you can't send it on there, Edsby is also fine. Whatever is faster.
Okay, let me send it to Etsy and you can post it in chat. How about that?
Yep. That works. Okay, yeah, got the link.
I'm going to share my Tinkercad now.
Tinkercad. Okay, can everyone see my Tinkercad now? Am I sharing?
I don't think so. Not
Okay,
yet.
hang on. Hang on, I'm not sharing. How about now?
Yes, we see it.
Okay, so when you first sign into your Tinkercad, it'll look something like this, where you have 3D designs. So on the left-hand side, you need to click on circuits. So you should be logged into your Tinkercad, and I've asked that you set up an account, so you should be able to create a new circuit. The one we are going to create is the one we're going to start with. So we are going to do a push button with an LED. I'm going to show you what this is going to look like. I'll do a simulation. And if I click on the push button, my LED goes on. I click on it. Goes on for like half a second, 1 second. Get the push button. There we go. Okay, so you can, if you're on Tinkercad too, we can create this together. So I'll go back and I will start a new circuit and we'll draw all the lines and develop this together. So I know that you now can't see my circuit, but on Google Docs, you should have a picture of what the circuit looks like. So what you want to do is, on the left-hand side, you're going to need a breadboard. For all of you that are new to computer technology, a breadboard is a way of building circuits that allows us to not solder all the components together. Underneath the plastic on the top is all copper. So when you, for example, like a resistor, and you stick it through, it's got pins, you stick it through and it connects to that copper and makes a connection. So you'll notice that all of these lines up at the top, this is all the negative line, this is the positive line, these are all connected. And then on the bottom, these are all connected. And then our rows are connected. You'll see if I hold my mouse there, it shows you, it draws like a shadow around all the connected lines. And then these on the bottom are all connected in groups of 5 in a row. Or sorry, not a row, a column. And then there's a trench down the middle which separates the two. So those are not connected across the trench. Okay, so we need an LED. Oh, we need our Arduino board too. Okay, and we're gonna need, so if you have a question as we're going along, just feel free to jump in. You can unmute your microphone and ask a question. You can type in the chat, any way you want to ask the question. Okay, so LEDs. So I need to point out that the LEDs have a positive and a negative side. So let's see if you can, yeah, it doesn't really show on the picture. So there's the anode side is the positive side. The cathode side of the LED is the negative side. If you're holding up an LED in front of you, one that you get in your kit, it's going to have, the anode side is going to have a long leg on it, and the cathode side is going to have a shorter leg on it. So that's how you're going to be able to tell the difference between the two. So on the positive side, we need to connect a resistor. So I'm just going to rotate the resistor. You don't have to, it just fits in better. So you're going to add a resistor onto the end of the positive side. We just want to resist the current a little bit and not make it too strong. Then after, so we make sure it's all in the same column. And then you're going to take a wire. So to draw wires, you simply click. It'll start drawing a wire for you, and then you just drag it wherever you want to and click again, and your wire is there. So as you can see, I've connected this positive wire up to pin 13 on our Arduino board. Now I could color this wire a red color. The other side of our LED, we need to connect it to the ground. So we click. And then we're going to bring it down to our ground on our Arduino board. And then we'll have one final wire from the ground to the ground of the Arduino. Oops. Okay, I'll draw that wire in later. Giving me some difficulties. Okay, so now we're going to go find our push button. So if you, an easier way is just basic components, switch it to all. You can type in the search push button. There's my push button. You'll notice the push button has 4 different pins on it. What you want to do is just straddle your 4 pins into the trench. You're only going to need to wire up 2 sides or 2 pins of that push button. So on the right hand side, we're going to connect that to our 5 volt. And then on the left pin, we're going to connect that to an Arduino pin, but we're also going to connect that pin to a resistor, and the end of the resistor is going to go down to our negative line. We just want to eliminate some of the interference that may come when we're pushing on our push button. That's why we connect it up to our ground line. So I'll let you finish wiring that up. I'm going to switch back to my other Tinkercad, and we're going to go through some of the code while you're continuing to wire this up. So up at the top of our program, we are going to have a constant variable called button pin, int button pin. So it's an integer type, and we've called it button pin. We're going to set it to =2. we're going to have another constant called integer LED pin, and that's going to be equal to 13. So we're going to have the button pin, this button, connected to pin 2. So if you'll notice, I'm D2 here on our Arduino, and then our LED is set up to 13. We're going to need another variable called button state. We want to know whether the button is being pressed or not pressed. So the button is always in a not pressed state or not on. When you press the button, that's when you complete the circuit. And so we're going to be testing whether the button is being pressed or not. So in our void setup, we have pin mode. So pin mode is a built-in function. We're going to send that built-in function our LED pin. So LED pin is set to 13. We're going to set it for output. So that's our LED. Pin mode, we're going to set to button pin. So that's our button. And that's pin 2. And we're going to set that for input. In our void loop, we want to constantly see whether our button state. So button state equals, and we're going to use the digital read function and send it button pin. So it's going to digitally read on pin 2 and see whether this button is being pressed or not. So if button state is a high, which means our button has been pressed, we are going to turn on our LED. To turn on our LED, we digital write out a high to that LED pin. So to pin 13, right here, we are going to write out a high, which turns this LED on. We need the delay so that we can see it with our eyes. And then we have our else loop, which would be a low or LED off. So any questions? Anyone else? Okay. What I am going to do, sorry, go ahead.
No, I was just going to say, I think everyone's just looking through the doc right now. So there's a lot more people on the YouTube channel, but no questions just yet.
Okay, so it's too fast, or can I move to the next one?
I think, yeah, you can keep going.
Okay, so what I would like to do, I know on the Google Doc that I've done it in project 1, 2, 3, 4. What I would like to do though is, in the interest of time, I want to make sure that we get to number 3, which because of COVID-19, I put together this project. It's called a social distancing detector. So what I'm going to try to, I have a video. I'm going to actually, I have the circuit in front of me, and I'm going to try to move my, okay, so I'm going to move my camera. Okay, hi everybody. Okay, so here's the circuit. Now let me move it so that you can see it. So it has an LED light, the Arduino. Sorry, my hand is right in front of the sensor, so it's constantly going off. So what this is wired for is it's got a piezo or a buzzer. It's got an LED, and it's got the ultrasonic sensor. So what to wire this up and put it on a battery pack, maybe put it on your belt or something. So when someone comes close, but when they're not close, it's no sensing. But when they're close to you, it buzzes and the LED goes off. But when so it's just like a social distance detector. So I thought in the interest of COVID-19, we could build this together. I'm just going to unplug it because it will constantly. So I thought we could build this together. So let's go to, I'm going to pull up my Tinkercad drawing for this. So what this entails is your ultrasonic sensor. Let me just zoom in on this guy. It has 4 pins on it. On the far left-hand side, it has the VCC, which is your power pin. Next to that, over to the right, you've got a, excuse me, a trig pin. And then you've got an echo pin. And over, last one on the right is your ground pin. So what happens is your trig pin will send out a signal. And then the echo pin will see how that signal, so it's receiving, how that signal is going to bounce back. And that's how you calculate out the distance of an object. So if I run this in our simulator, and then I need to move this down. Let's see if I can. There we go. We need some more space at the top. Okay. So if I run this, you'll see that I've got this ball. It's giving feedback because of, but you'll see that when you run it at home, you can manipulate that ball to sense the sensor of objects in front of it or not. Okay, so let's get building this project. Oops. Okay, so we've got the LED connected on our breadboard. So the 3 things you're going to need, well, more than 3, but you're going to need your Arduino, your breadboard. You're going to need a piezo, which is like a buzzer that sounds. You're going to need your LED, you're going to need your resistor, you're going to need lots of jumper wires, and you're going to need your ultrasonic sensor. So add all those items. Let's take a look at how this is wired up. So we're going to wire up our VCC pin of the ultrasonic sensor to our red line on our breadboard. We're going to wire up our trig pin to pin 12 on our Arduino. The echo pin is going to get wired to pin 11 on our Arduino board. The ground pin on your ultrasonic sensor is going to run down to your breadboard on the ground line, or this little negative line. Your piezo just simply needs to be wired to a pin on Arduino. So we've chosen for this one 7. And the other line of the piezo just runs out to ground. Then we have our LED. So your LED, remember the anode side gets wired up to the positive. So resistor, and then we've run this out to pin 6 on Arduino. The other side of your LED, so the cathode side of your LED, runs down to your ground line. Now I've connected my whole ground line to the Arduino ground line, and the positive line, I've connected it to the positive line of our Arduino, which is your 5-volt line. So if you look at your Arduino, you've got 5 volts. You hold your mouse over near it, it'll show VCC or 5 volts. These two lines on the back, what I'm doing is completing the circuit. So if things are connected across the trench, I know that this is not connected, so I connect them with a wire. So ground to ground and positive to positive across the board to complete the circuit. In our code window, so we've got a couple variables that we set up. We've got constants for integer trig pin. So remember we set that for 12. We've got the echo pin, and we've set it for number 11 on our Arduino. We've got the buzzer set up for pin 7. And we've got our LED set up for 6 on our Arduino board. We also need a long duration variable to measure duration of the signal and how long we're going to delay. We need a variable for distance, so distance in cm, or you can do distance in inch, but I'm doing cm. So in our void setup, this line here, serial.begin at 9600, that is setting up your serial monitor output. So for when you're doing your Arduino IDE at home, there's a little picture on the top right corner of the IDE. It looks like a magnifying glass. That's where you get your output. So we've got all our pin modes. So trig pin, echo. Trig pin is set for output. Echo pin is input because we want to echo back or receive how far that went out and receive it back. Your pin mode, so buzzer is going to be an output. Your LED is going to be an output. In our void loop, so we do a digital write out to the trig pin. We set it up for a low just to clear everything out, and we delay that for 2 milliseconds, microseconds. Then we do a digital write out to the trig pin of a high. We're going to do a delay, microseconds of 10, and digital write the trig pin to low again. And now we need, this is where we're going to calculate out our distance. So duration, we're going to say pulse in the echo pin to a high. So now we're receiving what the echo pin. We want to find out what is the echo pin receiving. Is it seeing something that it's bumping those signals off of? So is there an object in front of it or not? So distance in centimeters, we're going to take the duration, multiply it by so this is where the speed of sound comes in. You've got a formula, so 340, but then you've got to divide it by 2. Because we divide it by 2 because the sound goes there, but then it's bouncing back. So you don't want you want to actually say, okay, that object is in front of me 10 centimeters or 20 centimeters. So if you don't divide it by 2, you'll get that number doubled, and that's not what you want. Then we're just doing some serial.print lines out to our monitor. And then we're saying, okay, so if the distance is less than 100, then we're going to send a tone out to the buzzer, and we're going to write our LED up to a high. Else, we're going to have our LED low, and our buzzer is going to be off, or no tone. And that is our social distancing detector. So I know that's a lot of code to go through. And I know that we're running out of time on this session, but I wanted to show you really quickly one more one that I thought would be cool. Here it is. No, not that one. This one. So for the LCD display, which you're also going to get in your Arduino kit, and this one, so if we have time, let's go through. I don't know if we have time to keep going or not, or if they're going to cut us off right at the 2:30 mark.
Yeah, we're gonna need to wrap up soon.
Okay.
I'd just like to say huge thanks to Miss Beiko. We really do appreciate you taking the time to help us out. And I just want to remind everyone that viewed this workshop to check the YouTube chat and make sure to fill out the Google Forms to receive your free hardware kit. Okay, so I think that is everything. You can cut the live stream and stop recording, and we'll be done this workshop.
Okay, so I'd like to say a big, huge thanks to having me. I've had a great time. I hope you get tinkering with your kits when you receive them. The Google document is out there. Okay. So bye, everybody.
All right.
Okay, so you want me to end it for everybody?
Yep.